Hi, welcome to the PYB 350 overview videos. This video is going to give you a brief introduction into the concept of interactions. So in the last video, we looked at the situation where we had a one-way ANOVA with four conditions. Two conditions in which people had received caffeine and two conditions which they had received a placebo. Two conditions in which they've been exposed to sleep deprivation and two conditions when we had not. So when we did our complex contrast, what we were really doing was looking at the effect of caffeine and the effect of sleep deprivation. So the great thing about where we're going now as we move into factorial ANOVAs is that it allows us to look at multiple effects simultaneously. And what's most important, it allows us to look at the interactive effects between those independent variables. So for example, does sleep deprivation have a different effect on recency discrimination when the participant has also received caffeine or when they've received a placebo? So if we ran our experiment as a two-way design, we'd actually have three effects that we're looking at now. We'll be looking at the effect of caffeine. So that would be IV1. So that would be, as we did in our contrast, all the participants who'd been exposed or been given caffeine versus all the participants who'd received a placebo, regardless of what sleep condition they were in. A main effect of sleep deprivation, so that is the mean of all of the participants who were exposed to sleep deprivation versus those that had no sleep deprivation, regardless of whether they were given caffeine or not. And this new effect, that is the interaction between those two IVs, so the interactive effect of caffeine and sleep deprivation. So an interaction effect is simply the extent to which the effect of one factor differs across the levels of the other factor. So for example, did receiving caffeine reduce the negative effect of sleep deprivation on recency discrimination? That's essentially the same as asking, did caffeine and sleep deprivation interact with each other? So let's have a look at the case where they have interacted. Okay, so here we have the people who were exposed to sleep deprivation and received caffeine. And look, their recency scores are much better than the people that were exposed to sleep deprivation and received no caffeine. Okay, whereas the people who did not or were not exposed to sleep deprivation, they actually did better when they received no caffeine. So when we have crossed lines like this, it's saying that the effect of one IV is different depending on what condition of the other IV they were in. That's what's known as an interactive effect. Let's have a look at a couple of graphs that show us main effects, but actually no interactions. So here, let's have a look at this graph. Here we have the people who were exposed to sleep deprivation, and here we have the people who were not exposed to sleep deprivation. And you can see, regardless of whether they were given caffeine or not, the effects are quite the same for them. So here are the people who were exposed to sleep deprivation and received caffeine. Their scores are pretty much the same as the people who received or who were exposed to sleep deprivation but didn't receive caffeine. Whereas we can see there has been an effect of sleep deprivation. There's a large gap between the lines representing the people in the sleep deprivation condition and those in the non-sleep deprivation condition. So sleep deprivation has had an effect, but the lines are both parallel. So this is the effect of caffeine travelling across this way. And we can see that whether they received caffeine or not didn't really have an effect on their dependent score, their scores on the dependent variable. So this graph would be an example of a main effect of sleep deprivation. You see the gap between the lines. No main effect of caffeine because the lines are straight, and no interactive effect because the effect of caffeine has made no difference to the scores of the participants. The only thing that's made a difference is whether they were in the sleep deprivation condition or the non-sleep deprivation condition. Okay, so here now is an example of where we've got a main effect of caffeine, but no main effect of sleep deprivation. Okay, so here we can see there's no gap between the lines really here. Yeah, so it didn't really matter whether they were in the sleep deprivation condition or the non-sleep deprivation condition. Yeah, their scores were very similar. In this graph, what's had an effect is receiving caffeine. Yeah, when they've received caffeine, regardless of their sleep deprivation condition, they've done much better on the DV than when they received no caffeine. Yeah? Again, the lines are parallel, they're not crossing over each other, and so that is an indication that there's no interaction between their effect, between those IVs. Yeah? There's a main effect of caffeine. Yes, the people who received caffeine did better than the people who didn't receive caffeine, but there's no effect of sleep deprivation, and the effect of sleep deprivation was the same for the people who'd received caffeine and non-caffeine. So there's no interaction. Okay, interactions can occur in a few different ways. Let's have a look at this example. Okay, so for the people who did not or were not exposed to sleep deprivation, yeah, caffeine or no caffeine has had no effect on their scores on the DV. Here we can see that there. Whereas the people who were exposed to sleep deprivation, caffeine has improved their scores in comparison to the people who did not receive caffeine. So in this case, there has been an interaction between caffeine and sleep deprivation in that receiving caffeine, yes, has mitigated the effects of sleep deprivation. And so you can see once we have an interaction, the main effects or the effect of sleep deprivation or the effect of caffeine, you can't really talk about them by themselves. They no longer make or tell the whole story. The whole story here is that, yeah, caffeine has mitigated the effects of sleep deprivation. Yeah, so when there was no caffeine, sleep deprivation resulted in a worse score on the DV, but when they received caffeine, that difference was taken away. So an interaction essentially means that the effect of one factor differs across the levels of the other factor. So as I said, if we have an interactive effect, it means we can no longer talk about our main effects of each individual factor because we actually know that those effects are different at different levels of the other IV. Yeah? In the case I've just shown you, what was the effect of sleep deprivation on discrimination? Well, it depended on whether they received caffeine or not, didn't it? What was the effect of caffeine on on recency discrimination? Well, it depended on the level of sleep deprivation. So these more complex designs that we're going to be moving into and looking at over the next couple of 2 weeks are fabulous in that they allow us to ask much more complex questions. Not just about the effect of sleep deprivation or the effect of caffeine, but do these IVs work together? Does caffeine actually compensate for the effect of sleep deprivation? That is a more complex question. In other words, does caffeine interact with sleep deprivation in its effect on recency discrimination scores? So now we can have designs where we include multiple independent variables and their interactions into a single design. So now any individual score is influenced by the level of sleep deprivation they experienced, whether they received caffeine or not, and the interaction effect between those two conditions. So everybody's score is made up of, everyone's score in that particular experiment is made up of the effect of being in the caffeine or non-caffeine condition, the effect of being exposed to sleep deprivation or not, and the interaction between those two things. And that's how we would write it. The effect of variable A, the effect of variable B, and the interaction between the two, and of course any individual sampling error. So what did our results actually look like? Well, we kind of can probably have a good idea of that from the results of our contrasts. In terms of our recency discrimination scores, the people in the sleep deprivation condition did much worse than the people who were not exposed to sleep deprivation. Caffeine, we can see, had absolutely no effect on those scores, and there was no interaction between caffeine and sleep deprivation. Having caffeine didn't make the people in the sleep deprivation condition score any better. Let's have a little look at another example. Let's say in the same experiment, we also measured the participants' confidence in their judgments on a 5-point scale from not at all confident to very confident. And we can see the results that we get here tell us a slightly different story. In this case, the people in the control condition had the same level of confidence in their recency judgments, whether they received caffeine or whether they received a placebo. However, the people in the sleep deprivation condition, those people who are exposed to sleep deprivation, felt more confident in their judgments when they were given caffeine than when they were given a placebo. So in this case, we do have an interactive effect between sleep deprivation and caffeine. There's a sleep deprivation by caffeine interaction. It tells us that the effect of one factor is different depending on which level of the other factor we look at. So the thing to remember is, as soon as we have a significant interaction, we can no longer interpret our main effects, that is, the effects of our ideas, independently. We have to look at the effects of them together and explore and follow up the interaction. I would encourage you to, if you haven't been to the workshop for this topic, to please make sure you have a look at the interaction activity sheet on Blackboard. There'll be answers up after the workshop as well, just to make sure that you really get your head around what an interaction is and how to read graphs and tell if there's main effects or interactions, because this is going to be a big part of what we're doing for the next couple of weeks, and you'll need to understand that for your assignment.